So, okay, friends, a number is picked from 1 to 20, both inclusive. Find the probability that it is a prime. Okay, that means he has chosen 1 to 20. Both numbers are included. Okay, let us assume that there is slips are there, some tickets 1 2 3 4 5 6 like this 20 tickets are there, they are numbered 1 to 20 and they are put in a box. When he randomly picked up one number, that should be a prime number. That means the ticket should contain a prime number. Okay, now what is sample space here? Sample space is, how many are there? Sample space, so the total number of tickets 20, 1 2 3 4 5 6 7 8, all 20 numbers are written. That means the total sample space 20 numbers are there. Now yes, he is picking up and asking us what is the probability. It's a prime number. Out of these 20, how many prime numbers are there? We know that what is a prime number. Prime number must be a number that is divisible by 1 and itself only. That means there should be only two divisors for the given numbers, itself and 1. So such numbers are, how many are there between 1 and 20? 2, 3, 5, 7, 11, 13, 17, 19. Only these are there. These are all these numbers. But 2 is there means divisible by 1 and 2 only. 3 means 1 and 3 only. 5 means 1 and 5 only. Like that. So there are, how many are there? 8 are there. That means the favorable conditions are favorable number of events is 8 only. So total is 20. So what is the probability of getting a prime number when picked from this given 20 is 8 by 20. It is 2 by 10. So another problem. A page is opened arbitrarily from a book containing 200 pages, 1 to 200. What is the probability that, here it is, what is the probability that, here this is not printed, this is that the number of page is a perfect square. That means he has taken a book that contains 1 to 200 pages, because we know that in any book the page number starts from 1. So 1 2 3 4 5 6 like 200 pages are there. He randomly picked one page. So that page number should be a perfect square, he is asking. So what are the total number of pages here is 1 2 3 4 5 6 7 200 means 200 pages are there. This is a sample space. Now perfect, how many perfect square page numbers are there is in 1 to 200 means 1. 1 is a perfect square. Why? Because 1 into 1 is 1 only. Sorry, this is 1. 1 is 1 square only. Okay, 1 square. Okay, now 2 square, 3 square, 4 square, 5 square, 25, 6 square, 7 square, 8 square, like this. There are, how many are there? 13 square 116, 14 square 196. So 15 square should not come. Why? Because 15 square is 225. It is out of the range. So there are total, how many are favorable? 14 numbers are there. That means out of these 200 pages, 1 to 200, only 14 numbers are there which are perfect squares. Therefore the probability of happening is favorable by total. 14 by 200, it is 7 by 100. Okay, next problem. See, this is, suppose S is sample space, means all these sample space contain total possibilities, total number of events. This is a sample space of a random experiment. Suppose if I random experiment, if I toss a coin, what is a sample space? 1 and 2 will come. Okay, if I throw a die, what is the sample space? 1 2 3 4 5 6. That is a sample. The total, that is sample space. This is containing all possibilities, all. Okay, now this is, in this he is saying that the probability of getting 0 is 0. We don't know which type of experiment it is, but the probability of getting 0 in this sample space is 0. Probability of 1 is 0, 2 is half, like this. Okay, then show that P is a probability function. So remember here, what is a probability function here? Probability function must means the sum of all the probabilities of the given sample space. Means in a given sample space there will be so much of events will be there. I mean, so much of outcomes will be there. Okay, in a sample, the probability of these all outcomes, if I add, it should be 1. Then only it is a probability function. For example, if I take a, say for example, if I take a coin, suppose if I take a coin, suppose you have taken a coin, it will be tail or H. What is sample space here? Sample space is tail. Probability of, when I throw one time, what is the probability of getting tail? Half. What is the probability of getting H? Means we should write this like this. Here the sample space is, it should, when I toss Either T will turn up or H will turn. What is the probability of T? Half. What is the probability of H? Half. Total is how much? 1. Then this is the probability function. Like that, these are all, if I add probability of 0, 1, 2, 3 like this, it is P of 0, P of 1, all sum of must be equal to 1. So 0, 0, half, 1 by 4, 1 by 4. If I add, it is 1. Therefore, this given is a probability function. Right? Hope you understood. Now, again same, there are another problem. Suppose S is a sample base in a random experiment. 1, 2, 3, 4, 5 are the events in that total events. Given that probability of 1 is happening of 1 is 0.2. The probability of happening is 1 is 0.1. We don't know what type of experiment is, but simply 1 getting is 2 and 2 getting is 0.3, 3 getting is 0.2, so on. What is the probability of event of 5? Okay, this is event 1. Getting 1 is event 1 is it. Probability of 1, probability of 2, probability of 3, probability of 4. What is the probability of 5 is asking. Now here very simple. As we have discussed that probability function means sum of all probabilities must be equal to 1, definitely. If it is not 1 means it is not a probability function. So 0.2 plus 0.3 plus 0.4, zero point 0.3 plus 0.1 is plus 0.5, because total all probabilities, there are 5 events are there, all sum of the 5 events probability should be equal to 1. So this all 0.9 plus probability of 5 must be equal to 1. We don't know what is the probability of 5. We have to find out. Then that must be probability of 5 must be 1 minus 0.9. That means 0.1. That means the probability of this P5 must be 0.1. Then only this will become a probability function. Okay, hope you understood. We'll stop here.